Hello there friends. In today's video we're going to talk about how I made this, which is a water manifold. It basically allows me to control how I cool the condenser and the deflag for my still. I think it's wonderful, but to take you on this journey we have to jump back almost a year ago to September of last year. So the way I went around planning this water cooling system was I started with a couple of very rough sketches around how everything would work and what I'd want to be able to control coming out of the product condenser and then into the deflagmator. It started to get challenging because I realized that once I had something attached to here that would have a branch off for the water escaping from here and then a T to switch over to go over to here and a valve to control the flow of that switch, as well as a bypass to make that go through faster if I needed to quickly change things. There's going to be a lot of weight on this particular piece, put a lot of pressure on this little connection here. And so I started planning around how I could fix this problem, and I came up with what you would have seen in the beginning of this video, which is a water manifold, which basically means that it's like a switchboard for your water. So I started some slightly more complex sketches around what kind of pieces I'd need. I worked out exactly what I'd need and put it all on here, and then took to AliExpress to find those pieces and found that half of them don't exist. So after much toing and froing, I finally came up with this schematic that showed me exactly what I'd need to make the board, and the sizings, the type of ends, the threads, everything worked out so that it would work. I've ordered half of it. Maybe 1/8 got either sent incorrect sizings or got sent back. But I've got a whole ton of threads here and things that I'm going to start piecing together to figure out what I still need, and also just to get it marginally functional so I can at least run it in pot still mode and then have a way of having the water be sent out in a way without flooding my garage. The genesis for this idea came when I started watching some videos from a channel called Northern Brewer TV. It's a fantastic YouTube channel that just covers off a whole bunch of different brewing and distilling techniques, and in some of their videos where they were distilling, they had a sort of lab setting at a local distillery where they had something similar to what I wanted to create. I saw a lot of benefit in having the ability to be able to control the taps for what goes on and what goes off at certain times during a still run. This also really fed into my obsession with having everything able to be packed away nicely and without hoses hanging and dangling everywhere, which I've spoken about in previous videos. And then the other big benefit of this as well is having the controls removed from the still means that there's less likely scenarios of you burning yourself on the hot copper or steel elements while reaching around for taps. So that was a big plus as well. Alright, this is test number 1 for the mid-stage section, because I would test the product condenser initial cooling stage, but I don't yet have the thermometer for the groundwater temperature gauge in yet, because I need a reducer that will fit onto there, and I keep ordering the wrong sizes. So this is stage 1 here. That'll go to the condenser, it'll come back, it'll flow into here. But at the moment I just have it hooked up to my hose with the valve waiting to go on. And then what happens here is it'll flow through here and give me a temperature reading of the water coming off the product condenser. And then this gauge will normally be half open, or all the way open if I'm in pot still mode. But if I'm doing reflux distillation, it'll be half open. And then this needle valve here will control the flow of the water through to... Oh, I can hear my hose struggling, so I'm going to turn that on. Talk about the rest later. Here we go. Oh, got to turn that valve off. Oh, that was nearly a mistake. Okay, here we go. Turning on. Water's coming through. Perfect, and it's flowing through. There are no... I expected there to be a couple of leaks, but there are actually none coming out. Just open that valve all the way up. Hefty-loosey. There we go. So that needle valve will take... So if I open this, we might get a little bit of water coming out here. Yeah, perfect. That'll go through to the final port here, which will go either to wastewater, or when I get into water circulation, it'll recirculate back into the flow. You can see temperature gauge here is... I was expecting this to dip a little bit. Maybe it needs some more flow before it dips. tap is running very slowly. I also have this bypass, so if I suddenly need to put it into full reflux, I can open that valve right up, I can close this valve right off, and I can get a full flow through the reflux condenser and stop anything coming out the product condenser. So this valve here will go directly to the reflux condenser, and then, as per the schematic, it'll come back to another point over here, which I haven't ported in yet. That'll come over, elbow joint, come down here, and reconnect here with this guy, so that everything's gravity fed from this point. There shouldn't be anything going back up, and it should pull it all out and away from the overall manifold. Okay, so we're here just making some more rum. Who would have figured? And I've had this setup now running for a couple of weeks. I've done maybe 3 or 4 runs on it just to kind of give it a thorough bit of a go and play around with. Learned a few things, had to make a few adjustments. A couple of parts were faulty that I've had to replace, but it's ultimately working fine at the moment. It just means I have to have a whole bunch of additional hoses for it until I can finally move off the water mains and get a pump for myself. So one of the first things you'll notice is that this guy here, this is just running into itself, and that's because something I didn't anticipate is when the water is running out here on pot still mode, there's no valve or anything in between here and here, and so it runs down. You would have thought gravity would pull it out this way, but of course that's not how pipes work. So I had a little bit of exit water running up and over, and then shooting out here quite forcefully all over my workstation. So yeah, we've just got this little connector to itself, so that if for whatever reason water starts, I don't know, coming through one of these other guys. Is that even going? I feel like that's not even going. Ah, it's because I haven't turned the water on yet. Ha! Let's turn that on. There you go, you can see it now. You can see it building up here. You can see it coming along here. And you'll be able to see it in a moment dripping out here. This is some very forceful water. I turn the tap on, the tap squeals if it's at just the right spot. So I've got it turned on full bore because I'm doing a stripping run. It doesn't really matter too much. This portion here, this is just temporary, okay? So it's going to have one of these fixtures with a footing on it, but what happened is that was leaking. The thread had basically gone right through. When they carved the thread, it went straight through this stainless steel, and it was pissing out everywhere. So got a new one on the way. I damaged the temperature gauge that was there when I was taking it apart, so I'm going to have to replace that too. Frustrating, but all necessary. Ultimately, I'm happy with what we've got. This is only phase 1. We've got phase 2 still to come. The other cool thing about it being on this pegboard is I've got this little alarmed thermometer, and that just magnetizes on, which is great. Ultimately, what I'll need to do for the deflag out is just get a little cap. So this will always have a little cap on it or be connected to. You can see there's a couple of drips coming out of various places, partly just because I need to find where they are and tighten them up, and partly because the amount of pressure that's going through this at the moment is way higher than what will be the ultimate outcome for this. So that's where we're at the moment. So the water manifold is beginning to take its final form. That light won't always be there, but it's like I had a great idea, and it's come to fruition. So we've got the still here set up with a couple of bubble plates. We've got our condenser piped in, and you can hear the hum probably of the pond pump circulating water through at a very even rate. Up here we have our cooling chamber. So the idea here is that this pot has a copper coil running through it, and I can put huge blocks of ice in there, ice cores, and as the water comes off the final drain over here, and it's piped in over here, it'll go through that copper coil and interact with some very cold water to quickly chill it down, and then it hits this main reservoir down here, and that's where it gets pumped back up. And as it enters back in, I've got a little temperature gauge here to gauge what that temperature is. If it starts to get above 20 degrees Celsius, I can make a decision to shut it off or to introduce more cold water into that reservoir. At the moment I'm just testing it out with some rum faints. So I'm going to run some rum through there and see what comes out the other end, if the water stays cool for a long period of time or if I need to change anything up to the design. What I've been doing with this is using the new water circulation system on a stripping run for the first time. What I found was using this system for a stripping run, the water heated up a lot faster and it was coming out at about 30 degrees Celsius towards the end of that run there, which isn't a lot of spirit. So bit of a challenge to fight with is that I need to maybe find a bigger reservoir so that the water doesn't warm up as quickly. It loses energy and heat as it enters that reservoir, and then also potentially finding some way of icing this entire container. I had it in the fridge, but maybe I need to have it in the freezer, freeze the whole thing so that water is completely chilled as it comes through. So it's been maybe an hour or so. We have gotten all the way up to 91 degrees Celsius on the temperature. I've got this to a fine art now where during a stripping run, if I set I've got both elements firing on the T500, I set the temperature gauge to 30 degrees Celsius. By the time I can hear that beeping to get down here and to get ready, so like turn on the water or whatever, by then it's bumped up to about 50 degrees Celsius. I managed to maybe get the water going a minute before we got first drips. So it's a good system so far, it's working really well. I'm thinking because this connection is just a normal audio jack, like a 2-pole audio jack, or is it a 3-pole audio jack point, I can maybe get a couple of extension cables and run it up. So if I'm upstairs doing something somewhere in the house, I can hear it. And then the other feature I'd look to add is maybe like a little Wi-Fi power point for the pump, where when I hear it beep, I can just turn the pump on from anywhere I am in the house, which would be great. One thing I've realized with the amount of stripping runs I've been doing lately is that if I want to stop the water from getting up to 30 degrees Celsius, I have to come back and turn one element off. So a stripping run takes a little bit longer, but it stops the water, because otherwise it's warm all the way up here. If I can keep the warmth just at this end, and through this process of cooling, keep it cool from this tank, and then that water there, you know, around 20 to 25 degrees Celsius, then we're golden. Potentially, and this might just be me overthinking things, but I think having a cooler, a chili bin, an esky as the reservoir tank might be a mistake, because there's no loss of temperature, like when it's cold, there's no loss of temperature from outside forces, but the water coming in is heating it up, and as it warms up it stays warm. So it might be better to have something like just a metal or a plastic tank. So the way that I solved the problem that we were having with the water getting too hot during a stripping run is I just ended up getting a freezer, and it's not the most elegant solution just yet. It basically just feeds through the wall there to the other side. I haven't even vacuumed up where I drilled the holes, because I'm not very happy with how straight they turned out. But yeah, this freezer, it's 100 litres, it's just filled with regular tap water, and just obviously you can't see with the lighting on this awful camera, but you can see I've kind of plumbed in everything so it can be closed and sealed. And effectively what I do is I just turn this on the night before so that it chills the water down, and then I do my stripping run, and we might lose a little bit of ice, but the temperature never really gets above 10 degrees Celsius, which is perfect for really knocking down those vapors. Just in case there's any problems, I've put a hot water cylinder tray underneath this, because there is a little bit of seepage. These obviously are just meant to hold ice, not huge volumes of water, so it really puts a lot of pressure on that seal at the bottom for draining out the thing, and over time it does grow some floaties. So I did put bleach in this at first and then realized the mistake, because it's lined with aluminium, so I drained that out, gave it a good wash, and at the moment it's again just tap water. But I'll probably look at some glycol or something like that in the future once I've done some research around whether my pond pump can actually handle something like that. And also point out as well that I ended up getting the Wi-Fi controlled power point, so I can actually turn on the pump and the freezer from a click of the button on my phone, and they turn on when in when I need them to, which is great. It just means I don't have to crawl into this tiny little cupboard thing and do anything in here. And just means that at a moment's notice, I can turn it off if there's a problem. Again, I also have manual switches and valves on the manifold itself, but it just gives you an extra level of control. The only thing I have to worry about is like a cyber hacker finding my IP and turning on the pump at night while things are disconnected. But again, I have all the points off, I've got hose clamps on everything. I think it should be able to hold up to the pressure of the pump if somebody was to do something insidious like that. The only thing I really need to do now is because everything is so cold coming through, all the stainless steel here just gets condensation on it as well, which is a bit of a problem. I just get a bit of a drip line. So I'm going to wrap a lot of these pipes and everything like that in some foam wrap just to prevent that from dripping too much. So that's really all there is to talk about today with this video, with this change that I made to my still setup. Obviously it limits where I can do my distilling to just this room, but I think the benefits of saving on water and being able to do it in a controlled space probably outweighs that just a little bit. I don't know what else is next for this series. I've kind of now got the ability to do reflux. I've got a whiskey helmet, which was the other big upgrade that I wanted to add, and you've kind of seen in videos along the way that I've been just using that. So I think the next phase is building a shotgun condenser and a parrot as well, so that I can keep a tab on what the percentage is coming out while I'm doing stripping runs. That's going to be a little way down the road. I'm going to get a little bit of help on that because I don't want to solder and then have it fall apart again. So I've got a welding friend who I need to hit up and get that sorted. But that's all money and time. So when the time and the money is available, that'll come out as well. But once again, as always, thank you so much for joining me on this journey. It's been a fun trip, and if you have any feedback, any thoughts, or any other ideas, I'd love to hear the hive mind and pick up tips where I can, so let me know what you think. And I'll see you in the next video.
I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright.